In this video, I'll show you how to use the graphing calculator to answer question number 9 from your Unit 2 study guide, test study guide. Get a blank screen on your calculator and then push the Stat button, Stat, and then your Edit button. You're going to hit Enter. And if you don't have a blank list 1 and blank list 2, then you'll want to clear those lists by hitting your up arrow once to highlight the list 1, hit clear, and then hit enter. Do the same for list 2, highlight list 2, hit clear, hit enter, and now you should have 2 blank lists. So you'll list the times in the left column, 0, 1, 2, and 3, and you'll list the heights in feet in the second column. So you have 6.1, 7.25, 5.95, and 4.6. So we've got the times and the heights. And what are these? These are heights at different times shown in the table. So it could be height of whatever thrown in the air. Find a quadratic model for the data. It's already telling you it's quadratic, so that's good. So we go to Stat, Calculate, Quadratic Regression, which is number 5. So you can hit the down arrow until you get to number 5 and hit enter. Or when you're here, you can just type a 5 and it brings you to the list. It brings you to this screen where it says we're going to make a quadratic regression model out of list 1 and list 2 data, and we're going to store that regression equation in Y1. So we've done this before where we hit the vars key, Y variables, function mode, Y1, enter. Enter to store that, and then enter to calculate it. And now we see we have our quadratic coefficients. So the quadratic coefficients are here, and we're going to go ahead and write these in. So we'll find the quadratic model, and let's write it height in terms of time. And we get height in terms of time as negative 0.625, so that's the A, and the A goes in front of the x squared, plus the B, 1.295, I'm running out of space here, plus 6.22. Okay, I had to pause the video, so I'm not sure exactly what I just said, but we just figured out our quadratic model for the data. Now, here you have a quadratic model. You get the 2 points if you have that. Use the model to estimate the height of the ball at 4 seconds. So keep in mind, that's the time. That T right there represents time. So if we want the height, and the H represents the height, right? The H is the height. So if we want the height at T seconds, then what we want is H, or at 4 seconds, we want the H of 4. And so if we want the H of 4, we're going to write down H of 4 is equal to negative 0.625 times 4 squared, put in parentheses, plus, oh, I forgot the T. I should have put a T there, sorry. There we go. So we did have a problem there. So the 1.295 was being multiplied by the T. So back to this. I messed up on that one, but I just corrected it. This is the quadratic model for the height at a certain time. This now is the quadratic, we're using the quadratic model to estimate the height at time 4. And so we just replace T in this equation with 4 to find the height at 4. And so everywhere we see a T, we put a 4, and then we put 0.622. Now, don't do anything by hand here. All you have to do is this, approximately equal to. Now, we go here, and we go back to, let's make sure our Y1 is what it's supposed to be. So our Y1 is our height, and the X on our calculator represents T, time, in our problem. And so if we want to know this Y1 value when T is equal to 4, then the height when T is equal to 4, then we're going to type in vars, Y variables, function, Y1. Y1, then with parentheses, we put a 4. So we want our Y1 at 4 seconds, and we hit enter, and we get 1.4. So 1.4 Doesn't seem right, but I guess it is because the ball is coming back down. I'll show you a different way that you can see that. So the height at 1.4 is not approximately equal to, it's actually equal to 1.4, and we want to make sure we put the unit of measure here. That's 1.4 feet because the height is in terms of feet. Now, if we went to the y equals, so do this for me. Go to the y equals, select the plot 1, and then before you graph it, you want to hit zoom 9 for zoom fit, or zoom stat. And then we want to adjust the viewing window a little bit because we want to see the height of the ball when t equals 4 seconds, and we're not seeing that right now. We want to get x max, again, the x represents the t, time, in our problem. And the x max, let's let that be 5. And then our y min, let's let that be 0. And then we can see a little bit better. And if we go second calculate, we can calculate the value of this function when x is equal to 4. So we can see that the cursor is now blinking down there at the height of 1.4. So when x is equal to 4, the height is 1.4. In fact, if you trace this, you can see, we're going to trace, we're actually going to trace the y1. So you can see what happens here if we go back. If we use the quadratic model, we could see the height at the beginning was about 6.24 or 6.1. Actually, I'm looking at the chart. So according to the quadratic model, the height is right there at about 6.24. And then as time goes on, we see the ball goes up, and then the ball comes back down, and we can see the different heights depending on the certain times. So let's look at the next one. When will the ball be at its maximum height? So part C, we're going to use the quadratic model. We're not going to use the table because the table of values only gives us some values and some times and some heights. That doesn't mean that the 7.25 is necessarily the highest point. In fact, if you look at the quadratic model that we came up with, it's actually lower than 7.25. So just use the quadratic model, though, to come up with the maximum height. So you do second calculate, maximum, and then we're going to move the cursor to the left of the high point, enter, and then we're going to move the cursor to the right of the high point, enter, to mark the right bound, and then we're going to mark the guess somewhere close, and we see when will the ball be at its maximum height. We see the vertex now. What we're going to do is we're going to write down the vertex. The vertex is at 1.036, comma 6.891. 6.89891. So now that we know the vertex, we say therefore at t equals 1.0, actually approximately equal to, t equal approximately equal to 1.036 seconds. That's when it says it's at its maximum height. And then what is the ball's maximum height? So according to this quadratic model, the ball doesn't actually go as high as what it said in the chart. That's okay. We're just going to use the quadratic model, and we would say, therefore, since the vertex is at, the y-coordinate of the vertex is at 6.891, we would say the ball went 6.891 feet, because that's the y-coordinate of the vertex. And there you go. If you want to draw a picture of it, that's great. And you just label the vertex, just like I have over here. All right.